The James Webb Space Telescope, often referred to as JWST, is proving to be one of the most extraordinary achievements in NASA's history. With an investment of several billion dollars, it was designed to be the most powerful telescope ever built. Its purpose is not only to look farther into space than any telescope before it, but to also look farther back in time, to the very beginnings of our universe. Thanks to this remarkable piece of technology, scientists are gaining entirely new perspectives on how the universe formed, how galaxies evolved, and even how life as we know it might have begun. One of the most exciting discoveries made recently involves a group of extremely old galaxies, what scientists call megagalaxies, that formed when the universe was still very young. At that time, the cosmos was a hot, dense soup of particles, filled with energy and matter that had only just begun to cool and settle into stars and galaxies. What makes this discovery so fascinating is not only how massive these galaxies are, but also how early they formed. According to researchers, these galaxies took shape just a few 100 million years after the Big Bang, which happened approximately 13.8 billion years ago. The James Webb Telescope has continued to investigate these early cosmic structures, and each new observation reveals galaxies that are even older and more distant than the last. These galaxies are so far away that the light we are seeing from them today has been traveling through space for billions of years. In essence, when we observe them, we are looking into the distant past, witnessing the universe as it was when it was still in its infancy. It's like opening a time capsule from the beginning of time. Among the most astonishing discoveries made by JWST is the presence of volcanic materials, specifically complex organic compounds that are considered the building blocks of life. These compounds were found in one of the ancient galaxies Webb observed. Scientists were amazed to detect these molecules, especially given the galaxy's great distance and age. These substances are not just any molecules. They are what are known as organic molecules, which contain carbon, the fundamental element in life on Earth. Carbon is a key component of amino acids, which in turn make up proteins, the essential components of all living cells. This breakthrough suggests that the conditions necessary for life may have existed much earlier in the universe than previously thought. It challenges long-held assumptions and invites us to reconsider when and how life might have emerged. This discovery alone is enough to stir deep reflection. What if the seeds of life were sown not only on Earth, but across the cosmos, billions of years ago? Webb's infrared capabilities allow it to see light that is invisible to the human eye. This type of light is especially useful in astronomy because it can pass through clouds of dust and gas that would otherwise block our view. Many of the earliest galaxies are shrouded in cosmic dust, which makes them nearly impossible to detect with telescopes that use only visible light. The Hubble Space Telescope, which has been in operation since the 1990s, was a monumental tool for its time. But compared to Webb, it's like looking through a window with the curtains half closed. Webb pulls those curtains back. In one particularly striking discovery, scientists detected organic molecules in a galaxy named SPT041847, which lies over 12 billion light-years from Earth. These molecules, called polycyclic aromatic hydrocarbons, are typically found in smoke, soot, and engine exhaust here on Earth. Although we often associate them with pollution, they are actually rich in carbon and quite common in nature. That they were found so far away in time and space is extraordinary. The structure of this distant galaxy resembles a ring of smoke, and the molecules found there help researchers understand how the chemistry of the early universe might have influenced star formation and perhaps even life formation on planets like ours. What makes it even more impressive is how scientists were able to detect these molecules in the first place. The James Webb Telescope benefits from a fascinating phenomenon called gravitational lensing. This happens when a large object, like a galaxy or a cluster of galaxies, sits between a distant galaxy and Earth. The gravity of this middle object bends the light from the far-off galaxy, magnifying and distorting it in a way that actually helps scientists see it more clearly. This effect was first predicted by Albert Einstein in his theory of general relativity, and Webb is now using it to unlock secrets from the early universe. Thanks to this cosmic magnification, Webb can study the composition and structure of galaxies we would otherwise never be able to observe. The implications of these discoveries are far-reaching. They help astronomers answer some of the most fundamental questions. How did the first galaxies form? When did life's building blocks appear? Are we alone in the universe? That such complex molecules can be identified from billions of light-years away, molecules we recognize from our everyday world, is both humbling and exciting. More recently, the James Webb Telescope made headlines again when it detected the most distant galaxy cluster ever observed, located roughly 30 billion light-years away. Taking into account the expansion of the universe, this cluster could be one of the largest in existence. It includes 7 galaxies that were once seen by the Hubble Space Telescope, but their distance and relationship to one another were not well understood until now. Because of the immense time it takes for their light to reach us, we are seeing this cluster as it appeared only 650 million years after the Big Bang. While it may appear modest in size from our viewpoint, simulations suggest that if we could observe it as it exists today, it would be a massive structure capable of influencing thousands of other galaxies through gravity. In another breathtaking discovery, a team of researchers from the University of Minnesota used Webb to observe a tiny galaxy that existed more than 13 billion years ago, about 500 million years after the universe began. Despite its small size, this galaxy is producing stars at an incredibly high rate. According to the team's lead scientist, Patrick Kelly, this miniature galaxy is only about a millionth the size of our Milky Way, yet it is forming new stars just as fast. This kind of rapid star production in such a compact structure is something astronomers had not expected, and it offers valuable clues about how galaxies evolved in the earliest epochs of cosmic history. Webb's wide field of view, along with the benefits of gravitational lensing, allowed it to observe this tiny galaxy in unprecedented detail. In fact, gravitational lensing made the galaxy appear 20 times brighter than it would otherwise be, enabling astronomers to study it thoroughly. This marks one of the first times we've been able to look so far back in time, almost to the very beginning of the universe. Until the launch of JWST, the only major telescope capable of capturing detailed images of extremely distant galaxies was Hubble. Hubble operates in visible light, while Webb operates in the infrared. Both have contributed enormously to our understanding of space, but Webb's images offer new clarity, depth, and resolution, especially in regions filled with cosmic dust. When comparing deep space images taken by Hubble to those captured by Webb, the difference is striking. Webb's images are not only sharper, but stars captured by Webb often display pointed patterns called diffraction spikes, a signature of the telescope's unique mirror design. Thanks to these cutting-edge technologies, what once seemed impossible is now becoming routine. Galaxies that were hidden in darkness are now visible. Details we never dreamed of seeing are now being studied. The James Webb Space Telescope is changing everything we thought we knew about the cosmos. As it continues to send back data, 2023 and the years ahead promise to be filled with discoveries that may rewrite our understanding of how the universe began, how it evolved, and what might lie ahead. Thank you for joining us on this journey through the stars. If you're curious about the future of space exploration and eager to learn what else lies beyond the night sky, be sure to stay tuned. There's much more to come.